17 has a couple little new notations, but basically it's the same, it's just longer. This would be quite a bear to probably put together by hand. So now that we have a little aid, as long as we know keep everything straight and we know how to use matrices on our calculators, we can make this happen pretty nicely. FE. Okay, let's see. I've got 1 right there. Now, what this means is this is a large molecule that's this compound with this connected to it. So this is all one molecule right here. So this whole thing has only one Fe in it, just like this is a molecule. So the molecules are separated by these pluses. So there's no Fe's there, there's 0 there, there's 0 there. And here it is again. See, it's the K3 times all of this, and then all of that times 3 more waters. So this is one piece. Okay, well, it looks like there's just one Fe in there because that 3 is connected to those parentheses. So there's one, I think Fe is iron, so there's one iron in all of that. Okay, carbon. There's 2, so out of all of that, there's just those 2. There's 2. There's none there. There's 2. And on this piece over here, there's 2 of them 3 times, so there's a total of 6. Let's look for oxygen next. So the oxygen's in all of this. Now this is all one piece, so there's 4 of them there, and then there's a single twice. So there's 4 and there's 2 more oxygen, so that molecule has 6 total. All right, oxygen's right here, well there's 4. Oxygen's right there is 2. Oxygen's right there is 4. Okay, let's count them up here. So there's 4 sets of 3, so there's 12, and then here's 3 more singles, so those 12 plus 3 more, so there's 15 oxygens in that piece. Okay, hydrogens, there's a pair doubled, so there's 4 total. There's 2, there's 2 more, there's none in that section. Okay, let's find the hydrogens here. So there's none there, but there's a double 3 times, so there's 6. And the last one, K. No K's there. No K. There's none there. Looks like there's 2 sitting right there. Okay, there's 3 of them. Okay, is that everybody? 1, 2, 3, 4, 5. We have 5 elements and 1, 2, 3, 4, 5. So it looks like we've got a 5 by 5. Okay, well let's see what happens with that. So that 5 by 5, let's put in all of those numbers. So we've got 1, 0, 0, 0, 1. 2, 2, 0, 2, 6, 6, 4, 2, 4, 15, 4, 2, 2, 0, 6, and 0, 0, 0, 2, 3. Go down and get my reduced row echelon form of matrix A. Okay, so the last column went away again, so that's good because we need it to be relative, so that's a good sign. So I'm going to go math, fraction, and jot this fraction thing down here. So here's what I have now. 1, 0, 0, 0, 1, 0, 1, 0, 0, 1 half, 0, 0, 1, 0, 1 half, 0, 0, 0, 1, 3 halves, and then the rest was a bunch of zeros. Okay, A, B, C, D, E basically equals 0. Okay, so this spot right here is the D spot. So that's telling us D plus 3/2 E equals 0. This one is C plus 1/2 E equals 0. This one's the B plus 1/2 E equals 0. This one's A plus E, 1E equals 0. So there's the relationship. D is negative 3/2 E. C is negative 1/2 E. B is negative 1/2 E. A is negative E. So the relationship then is A is negative E. The second spot is negative 1/2 of an E. The third spot is negative 1/2 of an E. The fourth spot is negative 3/2 of an E, and then we get to pick E. Okay, so what this is saying is, see, all of these are negative. Well, that's saying all of those are on the same side, and this one's on the other side. There's only one term over here, that's the E, and then all the other ones are on the other side. So that makes sense that we have a negative there. Okay, well, let's see. It looks like I need to pick E as 2, and all those fractions will become whole numbers. So that's going to make this one negative 3. It's going to make this one negative 1. It's going to make this one negative 1. It's going to make this one negative 2. Now, all those negatives means is they're on the other side of the arrow, the balance arrow, as this one. So I don't really care. I'm just going to take the absolute value of all of those. So there's the relationship. 2, 1, 1, 3, 2. So 2 of these, 1 of those, 1 of those, 3 of these gives us 2 of that thing. Okay, that's the balance. Oh, I hope it balanced. Maybe I shouldn't have circled that in until I've checked them all. So let's come over here now. I'm gonna get me the element list. So, did we get it to balance? There's an FE twice. So this side has 2. On this side, there's an FE twice. So that one checks out. Let's do carbon next. Okay, there's some carbon right here and right here. So let's take a look at it. There's 2 of them twice. So far there's 4. And then over here there's 2 of them once. So that's 2 more. So I've got 4 and 2. So the carbons over here are 6. What about the carbons over here? There's 2 of them 3 times, so that's 6 of them, but then it's doubled. So it looks like there's 12 on this side. I'm probably just missed something over here. So there was 4. There's 2 more is 6. Oh, sure enough, I missed these. There's 2 3 times, that's 6 more. So I had 6 and there's 6 more. So it looks like the carbons are 12. Oxygen. There's 4 twice, so that's 8. Now, this 2 is on all of this. So let me count it. There's 4, and then there's 2 more. So there's really 6 oxygens in this piece that's been doubled. So 6 doubled, so that's 12 out of this first piece. Oxygens here, there's 4 more. I'm going to jot that down as 4 more. Oxygens here, there's 2 more. Oxygens here, there's 4, 3 times, so that's 12 more. So it looks like the oxygens on this side are 12 and 12 is 24, 25, 26. So it looks like to me there's 30 oxygens on that side. Let's see if there's 30 over here. So there's 2 of this big, this
excuse me. There's 2 of these. So there's 12. And then 3 more for 15, doubled. So sure enough, there's 30 oxygens on that side. What about hydrogen? Okay, there's probably lots of hydrogen. So there's 4 that have been doubled. So 4 that have been doubled is 8. I'm just gonna keep a running total like I did last time. There's 2 more. And there's 2 more. So 8 plus 2 plus 2. So it looks like there's a grand total of 12. Are there 12 on this side? Okay, well there's 6, and that whole molecule's been doubled. And the last one, I'll put the K up here. Well, there's none there, there's none there. There's only some K's right in this spot. So there's 2 of them 3 times, so that's 6. And over here, there's 3 of them 2 times, so that's 6. So there's our element list. Everybody is balanced. All right, 18 looks a little bit shorter. Now, if we had to do this by hand, though, trying to get this 7 to go to a 1, I got a 7 and a 1. Then for oxygens, I got 4 against 3. That's hard. Hydrogens, 6 against 2. So it would probably, these are weird numbers to try to get common. But we don't care with our matrix. The matrix doesn't care how ugly they are, how far apart they are. Here are the carbons, there's 7, there's none, there's 1, and there's none. The hydrogens, there's 6, there's 0, there's 0, there's 2. The oxygens, there's 2, there's 2, there's 2, and there's 1. Okay, I'll let my magic machine do the rest. Okay, it's a 3 down and 4 across, so it's a 3 by 4. I'll get those numbers in there quick. 7 0 1 0 6 0 0 2 2 2 2 1. Okay, reduced row echelon form as a fraction. Okay, there we have it. So I've got 1 0 0 1/3, 0 1 0 5 halves, and 0 0 1 -7/3. So there's the row echelon diagonal. A, B, C, D equals 0. So this one right here is telling us that C minus 7/3 D equals 0. This one is telling us that B plus 5 halves D equals 0. And this one is telling us A plus 1/3 D equals 0. So my first number relationship, if I'll take this 1/3 and move it to the other side, so it'd be -1/3 D. Taking this and moving it to the other side gives me -5 halves D. Taking this 7/3 and moving it to the other side gives me +7/3 D, and then I have D. So these 2 negatives are on this side, these 2 positives are on this side. So far, so good. Looks like if I pick a 6, they'll all become integers. So if I pick a 6, that'll be 2 times 7. If I pick a 6 here, that'll be 3 times 5. If I pick a 6 here, it'll be -2, and I want the absolute value. So 2, 15, 14, 6. So I've got 2 of these. 15 oxygen dioxides. 14 carbon dioxides, and 6 waters. Okay, there's the balance. And let's get the element list. Carbon. There's 7 twice for 14. So that's it, 14. Over here, there's 14 right there, 14 singles, and that's it. So the carbons are 14. Hydrogen. There's 6 doubled, so it looks like that's 12 with no more. Over here, there's 2 hydrogens times 6, so it looks like there's 12 hydrogens. Oxygen. Okay, there's 2 doubled, so it looks like there's 4 out of that piece, and then 15 doubled. So there's 30, and then those 4. So it looks like there's 34. Are there 34 over here? There's 14 pairs, so that's 28, and then these 6 more singles. So 28 and 6 singles is 34. All right, 19 should be a quick one. Sulfur 801. Oxygen 023. There it is. Got to get that in reduced row echelon. Two down and 3 over, so 2 by 3. 8, 0, 1, 0, 2, 3. So 1/8. So I've got 1, 0, 1/8 and 0, 1, 3 halves. There's my diagonal. Oops, sorry. There's my diagonal. So A, B, C equals 0. So right here I've got B plus 3 halves C equals 0. And up here I've got A plus 1/8 C equals 0. So moving the 1/8 to the other side, so I have negative 1/8 C in the first spot. Moving this one to the other side, negative 3 halves C in the second spot. And C is the one that I get to choose. These are on the same side, which yes, they are. So if I take 8 as the multiplier, that's going to make this 3 times 4. And that's going to make this one just negative 1. Okay, the negatives only mean which side they're on, so I want 1 of those, 12 of those, and 8 of these. So 1 of that, 12 dioxides, and 8 sulfur trioxides. So the element list, sulfur. This side has 8. This side has 8 singles for 8. Oxygen. Looks like there's 12 pairs, so 24. And here there's 3, but 8 of them, so 24. Okay, the last one would be very intimidating if it were not for our matrix idea. So now that we have this matrix idea, all we got to do is be careful to count them up, be careful to enter them in the calculator, and then do the relationship. So let's just start with the K's. This whole piece has 3 K's. Looks like there's none there, 0 there, 0, 0, 0, 0. There's 1 and 0. Okay, how about Fe? There's 1, that 6 goes to those 3, but not the Fe, so there's only 1, 0, 0, 0, 0. Okay, there's 1. That 3 goes to this piece, so there's only 1, 0, 0, 0. Sulfur. Okay, now this parentheses has 6 of them, so there's a single 6 times. Sulfur, none. There's a sulfur right there for 1. There's none there. Okay, there's a single 3 times. None, 0, 0, and there's a sulfur just once. Carbon. There's a single 6 times. So 6. This is a small r. That's not carbon, that's Cr. When there's a small letter, they go together. So that is not carbon. No carbon. There's 1 right there. That's the Cr again, so no carbon, no carbon, no carbon, no carbon, no carbon. Nitrogen. There's a single 6 times. Same thing, that's sodium, that's not nitrogen. That small a goes with that, so that's 0 nitrogen, 0, 0, 0. There's a single 3 times for 3. 0. There's a single just sitting there, 1, and then there's none there. How about what's next? Sodium, Na, that would be that one. So there's no sodiums in any of that, but there's 2 of them there. 0, 0, 0, 0. 0, 0, and there's 2 of them there. Cr, I don't know what Cr is, cranium or something like that. None there, but there's 2 of them. 0, 0, there's 2 of them. 0, 0, 0, 0. Oxygen. None there. Okay, there's 7. There's 4. There's 2. There's 4 3 times for 12. There's 3 times for 9. There's an oxygen. There's 3 of them. And there's 4 of them. Lots of oxygens. Hydrogen. Got 0 there. We have 0 there. We have 2 right there. 0 hydrogen. 0, 0. There's 2, 0, and 0. Okay, if I didn't make a mistake, then I just got to get it in my calculator. So get this thing turned on and get them typed in. So we have, how many down do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 down. And how many over? 1, 2, 3, 4, 5, 6, 7, 8, 9 across. So it looks like we got a 9 by 9. 81 numbers. Okay, well, let's just get them in. I won't call them out. I'll just type them in. Okay, there we go. See what it says. Well, that looks kind of nice. I'm going to math fraction that. Okay, so, see if I can get all this stuff on the calculator at once. So let's see. I'm not going to write all this matrix down now. A, B, C, D, E, F, G, H, I. So that's A being related to I. So I've got A plus 1/16 I equals 0. They're all related to I. So the next one will be B plus 1I equals 0. Here's the C and 29/8. So C plus 29/8 I equals 0. D is the -3/8. So D minus 3/8 I equals 0. A, B, C, D, E. So here's the E, which is the -1. So E minus 1I equals 0. F. So F is right here with the 16. So F minus 1/16 I equals 0. Okay, so I'm going to push down, hit the down arrow. So here's the G. G is the -29/8, so G minus 29/8 I equals 0. There should be one more for H. And there it is, H and -3/16. So H minus 3/16 I equals 0. Okay, let's put all that together. So the A spot, the first spot is right there. Move the 16 over, so that'd be -1/16 I. B, move the I over, -I. C, move the 29/8 over, -29/8 I. The D, move the 3/8 over, so that'll be 3/8 I. E, move the I over, that'll just be I. F, move the 1/16 over, so 1/16 I. G, move the 29/8 over, so it'll be 29/8 I. H, move the 3/16 over, so that'll be 3/16 I, and then I get to pick I. So what it's saying is 1, 2, 3, 4, 5, these last 6 things are on one side. 1, 2, 3, 4, 5, 6 are on that side, and these negatives, 3 negatives on the other side. 1, 2, 3. So I'm pretty happy with that. Okay, it looks like the common denominator is 16, so I'm going to choose 16. Okay, if that's 16, this one's 3. That makes this 29 times 2, so 58. 16, 1/16 of 16 is 1. This I right here is 16. This will be 3 times 2, so that'll be 6. 29/8 times 16 will be -58. That's just the 16. And that will be -1. Okay, I want the absolute values of those. These negatives just means they're all on the left side. Okay, so for the balance, it's saying I've got 1 of these, 16 of these, 58 of those, 6 of these carbon dioxides, 16 of that thing, 1 of these, 58 waters, 3 of those, and 16 of this last thing. There's the balance. All right, and lastly, I want to see how they all balance. I think I'm just going to put them right here, the K's. Okay, this side, there's 3 K's and no more. This side over here, right here they are 3 singles, so it looks like K is 3. The irons. Okay, I've got 1 iron, and that's it. The next iron is right here. There's 1. So there's only 1 iron. Sulfurs, okay. There's 6 of them here one time, so there's 6. Let's see, where's the balance equation? Right there. So there's 6 sulfurs. And here's 1 more 58 times. So 58 and 6 is what, 64? So there's 64 sulfurs on that side. Where are they over here? So there's 3 of them, 16 times. So that's 48 of them. And here's 1, 16 more times. So 48 plus 16 is 64. Carbon. Okay, there's 6. So this side has 6. There's a single 6 times, and that's all there is. Nitrogens. There's 6. That's all there is. So right here's some nitrogens. So there's a single 3 times, and there's a single 3 times. So 3 and 3, 6. Things are working out well. Sodiums. Okay, there's 2 of them, 16 times. So there's 32 of them. Here's the other sodium, 2 of them, 16 times. So there's 32 sodiums on both sides. The CRs. There's 2 of them, 16 times, so 32 of them. The rest of them are right here. There's 2 of them, 16 times. Oxygens. Okay, there's 7 of them, 16 times. So 7 of them, 16 times is 112. And here's 4 of them, 48 times. That's 192. So 112 and 192. It looks like there's 300 and something of those. 304 oxygens on this side. Wow, are we going to get 304 on this side? Okay, there's 2 times 6. There's 12 of them, 16 times. I'm just writing these down on my calculator as we go. Okay, here's 9 of them one time, so plus 9 more. Here's 1 of them 58 times, so 58 more. Here's 3 of them 3 times, so 9 more. And here's 4 of them 16 times, so 64 more. Add all that up. $304. Oxygens, I think that's 304. I'm going to go with that. Let me check one more thing. It might be 344. Here's 7 times 16, and here's 4 times 58. Yeah, it's 344. Okay, now I'm a little happier. And hydrogens. I've got 2 of them right there, 58 times. So it looks like there's 116 hydrogens. And over on this side, right here's the 2. I've got 2 of them right there at 58, so also 116. So there's the element list. The balance and the element list. Okay, so there we have it.